So on 431, we're looking at question 51. Okay, what is this asking us to find?
The derivative.
Which derivative?
The nth.
The nth derivative.
So you just put n in there somewhere.
So okay, when it says to find the second derivative, are you just putting 2 in there somewhere?
No.
No. So what we're going to have to do is try to see if we can find a pattern that is relating the derivative to which derivative it is. First derivative, second derivative, third derivative. So we're going to take the first, the second, the third, the fourth, and see if we can find some kind of relationship that exists there. So your first derivative would be 2e to the 2x. What would be your second derivative? 4e to the 2x. What would be your third derivative? 8e to the 2x. What would be the fourth derivative? 16e to the 2x. So are we noticing a pattern here?
Yes.
What is it that stays consistent?
The e to the 2x.
Okay, so we're going to go ahead and try to make a jump to this pattern. The nth derivative is definitely going to contain e to the 2x. What is our value of n in this statement? That's the first derivative, correct. Can you find some way to relate 1 and this number?
2 to the 1.
That's 2 to the 1. I don't know, let's see. What derivative is this? The second, and can you relate a 2 in there?
Yeah.
So that's really 2 squared. This one was really 2 to the 1. Let's just see if that pattern holds true. Is this 2 to the third?
Yeah.
Is this 2 to the fourth? So then if I want to take the nth derivative, this would be 2 to the nth. Okay. So for number 61, find the absolute maximum value of this function. We'll take the derivative, find the increasing and decreasing. But remember, with absolute value, you would also consider the end points. But did they give us a restricted domain? No. Is there a restricted domain for this function? Are there any restrictions? No. So that means that this exists on the entire number line, so you're not going to have endpoints to test in this for the absolute maximum. So we'll take our derivative, which would be 1 minus e to the x. What will I now do with the first derivative? And when I set it equal to 0 and solve, what am I finding? Your critical numbers. Excellent. So you end up with e to the x equals 1. How can e to the x equal 1? E to the 0 is what equals 1. So therefore we find our only critical number is x equals 1. So on a first derivative number line, remember you're going to label it as the first derivative. We're going to put in 1. Oh, x is 0. Thank you. That's what you said. That's just not what I wrote. So x is 0. Thank you, Katie. Bonus points. Less than 0 would mean a negative 1. So if you were to input negative 1 into this first derivative, what kind of value are you going to get? A positive or a negative?
It's positive. Yeah.
Positive?
Mm-hmm.
If you were to input a positive 1, negative. So we have a maximum because our derivative is increasing and then decreasing. I mean, our derivative is positive and then negative. So our original function is increasing and then decreasing, which will give you a maximum. And the question asks you to find the absolute maximum value. Remember, this tripped you up on one of those tests that we took because You gave me the answer of where it occurs, but not the actual maximum value. To find the maximum value, what do? Plug 0 in where? To the original function, correct. So if you put 0 into the original function, you end up with 0 minus e to the 0. -1. So is -1 our absolute maximum value? Okay, great. And then if we look at number 63, find the intervals of increase or decrease, find the intervals of concavity, and then find the points of inflection. Okay, so our first derivative would involve product rule. So we get 1 times e to the x plus x times e to the x. And in order to find intervals of increase and decrease, I've got to find those critical numbers and do the process that we just completed here. So what do I do to try to find these critical numbers?
Take out e to the x.
Factor out an e to the x. And then we have 1 plus x equals 0. Set each factor equal to 0. Can e to the x really ever equal 0? So that does not lead us to a critical number. This critical number turns out to be -1. And so then at this point we will do a first derivative number line test. Will you please use your, I don't guess you have to use a calculator. Couldn't you put in something to the left of -1 into this and figure out what sign it's going to be? We'll say -2. What sign is e to the -2? Positive. That's just 1 over e squared. And if you put in -2 here, so a positive times a negative would give us a negative. And then if I tested something over here to the right, let's say I try 0. E to the 0 is just 1. So that's positive, because that would be positive. So that tells us that f of x is decreasing from -infinity to -1 and increasing from -1 to infinity. And that answers part A. Now we need to find intervals of concavity. Which form of the first derivative do you want to use to find the second derivative? You like the factored form or the first form? Factored form? That'd be easy, just use the product rule. So let's use that form then. E to the x, 1 plus x. Okay, so we want to find our second derivative now. So the derivative of e to the x is just e to the x times 1 plus x. And the derivative of 1 plus x would just be 1. From this form, what could you factor out from both of those terms? So this is factor out an e to the x. When you take out the e to the x, what will be left over? 1 plus x plus 1, which you're right, Aaron, does turn into 2 plus x. Now we'll set this second derivative equal to 0 to find our possible points of inflection. This one again does not lead us to a solution, but we get x equals -2. So if we put -2 on our second derivative number line, if you put in e to the -3, isn't that positive? And then 2 plus -3 would be negative, so that tells us that this is a negative. If we used 0, we would end up with 1 times 2, which is positive. So f of x is concave down from -infinity to -2, and it is concave up from -2 to infinity. So doesn't that lead us to know that there is a point of inflection at -2 something? How do I find that something? Plug in -2 back into the original function. Isn't that just negative 2 over e squared? Okay, so we'll move on now to page 439. Find the inverse function, correct? So we're looking for the inverse. So what do we do for step 1 to find the inverse? Switch the x and the y, and then we just try to solve for y. So this would be x equals ln of y plus 3. Well, it's very difficult to solve for this, so I want to rewrite this log equation as an exponential equation. What is our base? E. What is our exponent? So e to the x equals y plus 3. Subtract your 3. So we have f inverse. I don't think they used f. No, they just left it as y. So really y inverse would equal e to the x minus 3. Okay? So if we look at number 63, anybody need a minute on 61? Okay. So then for 63, same directions, find the inverse. So I'm going to write it using x's and y's, and then I'll switch our x's and y's. So to solve for this variable y that's in the exponent position, I would need to rewrite it using a log equation. So this, what's our base? E. So a log base E means natural log of x equals, yeah, the exponent, y to the third. So cube root. So y inverse will be the cube root of ln of x.